Module 6, Section 4.4, Matrices, Basic Operations. Objectives: to understand the basic concept of matrices. Objective 2, perform addition and subtraction of matrices. Objective 3, find the scalar product of a number k and a matrix M. Calculate a matrix product. And Objective 5, perform matrix operations using a calculator. A matrix is a rectangular array of numbers written within square brackets. Here is an example. Each number in a matrix is called an element of the matrix. Sometimes we also call this as an entry of the matrix. This matrix A has got 9 entries arranged in 3 rows and 3 columns. If a matrix has m rows and n columns, it is called an m by n matrix. The expression m by n is called the size of the matrix, and the numbers m and n are called the dimensions of the matrix. Notice that the number of rows is always given first. We have a matrix A with 3 rows and 3 columns, so A is of size 3 by 3. A matrix with n rows and n columns is called a square matrix of order n. So we need to have the same number of rows and columns for a square matrix. A matrix with only one column is called a column matrix, and a matrix with only one row is called a row matrix. The position of an element in a matrix is given by the row and column containing the element. This is usually written by A sub ij, where I is the row and j is the column containing the element. For example, if we are given matrix A, the element 8 is part of the third row and the third column, so we can write it as A third row third column, A sub 3 3. So the value for A 3 3 is 8. To add or subtract matrices, they must be of the same order m by n. To add matrices of the same order, add the corresponding entries. To subtract matrices of the same order, subtract their corresponding entries. The general rule is as follows using mathematical notation. To add A and B, we need to add the ijth entry of A, which is written as A sub ij, to the ijth entry of the matrix B, which is written as Bij. Same thing with the subtraction. Subtract the corresponding entries. Here is an example. We have 2 matrices which are of the same size, 3 by 3 here, added to another 3 by 3 matrix, getting the sum to be another 3 by 3 matrix. In order to get the entries of the sum, what we need to do is we need to add the corresponding entries. So for example, if we add first entry of matrix A with the first entry of matrix B, we are going to get 4 plus negative 1, which is equal to 3. So that's how you get this number up here. You can also look at the other locations. 0 plus 8 will be 8. Negative 2 plus 9 will be 7, like that. Subtraction is done exactly the same way. We subtract the corresponding entries. As an example, we have 2 matrices A and B. We are subtracting between them, A minus B. So A minus B will have their entries calculated by subtracting the corresponding elements of the 2 matrices. For example, if you look at 3 2 locations, these are the 3 2 locations. Negative 6 minus negative 4, so that is how we get negative 2 here. You notice that the subtraction sign. Scalar multiplication. The product of a number k and a matrix M is the product denoted by km obtained by multiplying each entry of M by the number k. Number k is called a scalar. So in order to multiply a matrix M with k, we multiply every entry of matrix M with the number k, written like this: k multiplied with Aij. Example, find 3a and negative 1/2 times a, where a is given as a 3 by 3 matrix. Let's calculate this. 3 times a means every entry of a is multiplied with 3. So we will get 3 times 3, 9, negative 3, 12, 3 times 6, 18, then we will get negative 6, 21, 15, negative 30, 3 times 8, 24. So this is the matrix 3 times a. Same thing up here. If we multiply with the negative 1/2, which is another scalar, we will get the scalar product to be negative 3 by 2, positive 1 by 2, negative 2, negative 3, then you'll get 1, negative 7 by 2, negative 1 by 2 times 5 will be negative 5 by 2, then you'll get 5, negative 4. So that will be the matrix written as negative 1 by 2 times a. Matrix multiplication. Two matrices can be multiplied only if the number of columns of the first matrix is the same as the number of rows of the second matrix. The product will have the same number of rows as the first matrix and the same number of columns as the second matrix. Row by column multiplication. If we have a matrix of size 1 by 4, which is a row matrix, and if we have another matrix of size 4 by 1, which will be called a column matrix, we can multiply them by multiplying it this way. So you'll take 1 and then multiply with 5, 2 and multiply with 6, 3 and multiply with 7, 4 and multiply with 8. So you'll get the total sum to be equal to 70. This is how we multiply a row by a column matrix. We are going to use this operation in defining the product of two matrices. If A is an M by P matrix and B is a P by N matrix, the matrix product of A and B, denoted by AB, is an M by N matrix whose element in the ith row and jth column is the real number obtained from the product of the ith row of A and the jth column of B. If the number of columns of A does not equal the number of rows of B, the matrix product AB is not defined. Suppose A is M by P and B is a matrix of size P by N. If we cancel these middle numbers which are equal for them to be multiplied, what is left will be the size of the product. So A is M by P and B is P by N means product AB is defined and it will have a size M by N. Following is an illustration of the product of a 2 by 4 matrix with a 4 by 3 matrix. So the size is going to be 2 by 4 multiplied with a 4 by 3 matrix, getting size to be 2 by 3. That's what you are getting here, 2 by 3 matrix, 2 rows and 3 columns. Let's see how we can calculate the entries. So we take the first row and then multiply with each one of the columns here. So if I take the first row and multiply with the first column, my answer will be 1 times 1 plus 2 times 4 plus 3 times 7 and 4 times 10. When I add this to this numbers, I will get this 1 entry, first row, first column. So then we are going to repeat this. Keep the first row and go to the second column. So this is column 1, column 2, column 3. This is row 1. So 8 is obtained as the product of row 1 and column 2, just like we did it here. 1 times 2 plus 2 times 5 plus 3 times 8 plus 4 times 11. That will make 80. Repeat. Once we finish all the columns of the second matrix, we can move to the second row and repeat the same thing. Second row with first column will produce 158. Second row with second column will produce 184. and second row with third column will produce 210. This is what we call row by column product. Here is an example where the matrix product is not defined. Let's see the dimensions. The first matrix, if we label this as A and the second one as B, the size of A is 1, 2, 3, 4 rows, and you'll get 3 columns, 4 by 3 size. The second matrix will be having 2 rows and 4 columns. So if you look at these numbers up here, they are different. So that tells you that you cannot multiply them in that order. A times B is undefined. AB not defined. How about BA? If you reverse the order, then the sizes will match. B will have size 2 by 4. A will have size 4 by 3. So this product is defined and it will be of size 2 by 3. So this is okay, but AB is not okay. Matrix equations. So we need to find the 4 variables A, B, C, D so that this matrix equation is true. Notice that the first matrix will have its entries given by variables. So what we are going to do is we are going to do this matrix operation here, which is subtracting 2 same size matrices. Both of them are 2 by 2. When I subtract the corresponding entries, I will get A minus 2, B plus 1, C minus 5, which will be C plus 5, D minus 6, which will be D minus 6. So we get a 2 by 2 matrix on the left, and the right hand side is already a 2 by 2 matrix. So we are saying that 2 matrices are equal here, and 2 matrices are equal only if they have the same size and the same entries at the corresponding locations. So that helps you to come up with the new equations here. A minus 2 here, which is the 1, 1 entry, should be matching with the 1, 1 entry on the right. So that will give you this equation, A minus 2 equal to 4. So that helps you to solve for A by adding a 2 here. So we get A equal to 6. Then move to the next location. B plus 1 has to be equal to 3. So that is a new equation. So B value will be 2. C plus 5 will be matching with negative 2. Same locations. Solving that, we will get C equal to negative 7. And similarly, D minus 6 will be 4. D equal to 10. Matrix operations using calculator. Let's see how we can do this matrix operations on a calculator. First of all, we need to edit the matrices. We have 2 3 by 3 matrices. We are going to add them together. So in order to add these matrices, I need to edit them first. So I'm going to go to the matrix editor, which is second. So this X inverse key. So that is giving you the matrix menu here. So if you use the right arrow 2 times, you will go to the editor. And we need to actually edit the matrices under 2 names, A and B. So I'm going to hit enter. That will open the matrix A. So I need to change the number of rows to 3 because this is a 3 by 3 matrix. Use the right arrow. Number of columns will be 3. Again use the right arrow. It will go to the first row where we are going to type in the entries. Our first row will be 4, negative 3, 1. So I can type in the numbers 4, enter, negative 3, enter, 1. If you press enter, it will skip to the next row. So that way we can fill in the entries. 0, 5, negative 2, 5, negative 6, and 0. So that fills in the matrix A. So now we need to get another matrix, which is matrix B. So I need to go back to the matrix editor, quit this mode, come back to matrix editor, right arrow, right arrow. Now I need to go to second matrix B. So I'm going to put B as my second matrix. Size is again 3 by 3. So 3, right arrow, 3, enter, fill in the entries. Once you complete the editing, again go back to home screen. Then we are going to add these two matrices, which are A and B. So I need to call them. Go to matrix menu, matrix A, then use the operator addition. Go to the matrix menu, call the matrix B, and now we have A plus B. So if I press enter, A and B is added, getting the sum. This sum is going to be 3, -1, 4, 6, -2, 7, and 5, -10, 8. If you want to multiply a matrix by a scalar, you do the same operation. Once you edit the matrix A, suppose you want to get 5 times A. So it will be like 5 multiplied with matrix name A equals. So that will give you 5 times A. Now we are going to use the calculator to multiply two matrices. So we have two matrices, A and C. A is of size 2 by 3, 2 rows and 3 columns. C is of size 3 by 3, which is 3 rows and 3 columns. Notice that we can get AC because the sizes match. 2 by 3 with a 3 by 3 will produce a 2 by 3 matrix. Let's see how we can do this on the calculator. First of all, we need to edit these matrices. So go to the matrix editor and then put the matrix A under. So it is 2 by 3. So I need to change the size. 2 by 3. Entries will be 1, -4, 4, 0, 3, -3. Now I'm going to edit matrix C. So its size is 3 by 3. So I need to put the size here. The entries will be -2, 0, 1, and so on. Second mod or quit. And what I need is the product of A and C in that order. So I need to call the matrix names. Matrix name A. Operation is multiplication, so multiplied with matrix name C. Roll down. And then now if I press the enter, I will get the product of A and C, which is a 2 by 3 matrix. So AC is going to be the 2 by 3 matrix. -38, 25, 27, -15, -3. Let's see what happens if we multiply that in the reverse order, that is trying to calculate C times A. So if I do this operation with the C as the first matrix, A as the second matrix, C times A. So we get an error message, dimension mismatch. That means the matrix CA is undefined because of the sizes. C is 3 by 3, and if you multiply that with the A as the second matrix, it is to be multiplied with 2 by 3. So notice that these two numbers are not the same. So that means that you cannot multiply. So the calculator gives you an error message, dimension mismatch.